Okay, so we have here a sample problem. The goal here is to solve for F3. So let us first analyze the problem. We have here an object with a mass of 2 kilograms, and we have here three different forces. The first force is F1, 10 Newton with 30 degrees from the x-axis. Our F2, force 2 is 20 Newton along the y-axis. Um, this is our F3, but the given here is um, the acceleration of um, the object. So the acceleration of the object along this direction is 3 meter per second squared. So we have to solve for the force along this particular direction. Okay. So the same thing, since this is a vector quantity, we will have to get the x component and the y component per vector. So vector. So for vector F1, we have to look for that. And then F2, we could also even put here our F3, and this is what actually what we are looking for. So let's solve one at a time the values of these vectors so that we could solve uh, the goal of this problem. Now let's start with F1. So for F1, if we could zoom in this, or if we could extend this one, a line, this something like this. So we have here a right triangle. So this is our opposite, this is our adjacent. So looking for F1 along X must be this one, and our F1 along Y must also be this opposite. So with that, we could use solve for F1 along X. Okay, much better if we just put in all the formulas. Okay, let's say we have here F1X, and then we have here F1Y, let it be. For F2, we only have components along the y-axis. So we have here F2, that is our component along the y-axis, and we don't have any x-axis. For our F3, our x-axis must be F3 along x, and our y-axis must be F3 along y. Okay, don't forget to get the sum. So the total must be F net along x, and this one is F net along y. So we're not actually putting all the exact value per component. We're just looking for the actual equation that corresponding to each of those components. Okay, so our again main goal here is actually um, solving for f of 3, or the force along this direction. Okay, let's go back. So okay, based from the given, we already know our f net. Our f net is given by m times a. Now, since f net is the sum of f1 plus f2 plus f3, then we could have this equation ma equals to f1 plus f2 plus f3. And since we're looking for this one, okay, so we will rearrange our equation. We will end up to f3 must be equals to MA, okay, minus F1 plus F2. Okay, let us focus here, okay, in this one. Let us focus that equation. Um, if we have F net X, it should be the sum of F1 along X direction plus F2 along X direction plus F3 along X direction. Same goes for our F net Y, which is F1Y plus F2Y plus F3Y. Now let us rearrange the equation and solve for F3X and F3Y. So we'll end up with F3X will be F net X minus F1X plus F2X. Okay. On the other hand, here this will become F3Y and should be F net Y minus F1Y plus F2Y. Okay, this is the X component of our F3 and this is the Y component of our F3. Okay, now if we know the X and Y components of a certain vector, then our F3 must be the square root of F3X squared plus F3Y squared. Okay, this will be our equation in solving for F3. But before that, we have to solve our F3X and our F3Y. Okay, so let us first solve that one. Solve for F3X and F3Y. So for our F3X, our F net is the X component of um, since yes since F net is equals to MA, so our F net X must be M cos 50 times A minus our F1. We look at our F1 here is moving on the left, okay, then 10 Newton. Okay, so this is negative cos 30 times 10 Newton. Okay, let me just change this one to bracket. So plus our F2. If we look at our F2, we don't have X component for our F2. So that is actually 0. So let us further solve this one. So this is 2 kilograms. And this is cosine 50 times 3 meter per second squared. Okay, that's negative times negative, that's positive. So plus cosine 30 times 10 newtons. So let us use our scientific calculator and solve for this one. 12.5052 Newton. Okay, so this is the force along x direction of our F3. That's 12.52 Newton. How about our y components? Okay, so for our y, we use that equation. So F3y equals to our F net y is still m um, sine 50, okay, times a minus our F1y. So this should be sine 30 of 10, but since this is directed downward, this should be negative. Plus our F2y is nothing, just it's the same F2. So this is 20 Newton. So this is again 20 Newton. So let us further continue substituting. We have here 2 kilograms sine 50 times 3 meter per second squared. Okay, so that's negative. Negative sine 30 times 10, that's Newton. Newton plus 10 Newton plus 20 Newton. Let's see, let us use our calculator. 4.5963 Newton. Let's have the other one. So sine 30 is 5, sine is 1/2 of 10 is 5, so that's 15. Okay, so this is 15 Newton, and our F3y must be, so our F3y must be, that's actually negative 10 or 40 Newton, and this is our F3y. So we're not yet done. We have to actually solve for the value of our F3. So our F3 now must be the square root of F3x squared plus F3y squared. That is actually equivalent to, how much is the value? 12.52 Newton squared plus negative 10.40 Newton squared, and our f of 3 must be 16.28 Newton. So this will be our F3, and let us solve for the direction. Let us look for the direction of our F3. So the direction of 3 must be tangentially 1 of the absolute value of y, and so the absolute value of y is 10.40 Newton divided by x, which is 12.52 Newton, and we get an angle of 39.72 degrees, and this is our direction. This is the direction of the said vector. So this is the direction, and this is the actual value of our F3. So if we trace this, in our Gaussian plane. So this is roughly 16.28 and almost 40 degrees. So our F3 must be in this particular direction. So that particular direction, this will be our F3. Okay, and this is 16 point something. And that is actually reasonable.